You can start. Okay. Welcome to the May 28th, 2024. I would like to call it TAPR-HamSCI technical session. And I think we'll use that term from now on and disconnect it from a particular radio instance. Okay. I've had a good week. I was at Dayton, or actually 2 weeks, Dayton, participating in the Tapper booth and also leaning over and talking to HamSci people who are in the next booth over. It was a busy crowd, seemed to be successful. So that's about it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I also was at the Hamvention 2 weeks ago, and I saw many of you there in person, and I thought it went very well. I thought both the Tapper and the HamSci booths were quite busy. There were many forums. I know that there was a Tapper forum, HamSci ran a forum. I spoke in other forums. We had booth talks. There were all sorts of things that went on. I was able to bring two of my students with me. I think it went very well, and they had a good time. And so now uh, we're I got to speak to some Tapper people about the Tangerine and Clementine SDR projects. So we'll probably have some discussion about that tonight and some of the discussion I had at Hamvention. And then I'm also getting ready to go to Colorado. I'm going to Boulder tomorrow until Friday. I'm on a project called NASA Living with a Star focus science team. We're looking at the difference in gravity waves and traveling atmospheric disturbances between the northern and the southern hemispheres. So I'm taking 4 students plus Dr. Mary Lou West with me to Boulder, and Hillman's going to be there too because he's involved in it on the magnetometer side of things. So I'll see Hillman there as well, and we're going to be talking all about traveling atmospheric disturbances and waves in the two hemispheres. And it's so I've been very busy trying to get 4 student posters put together. JP Fox, who went to Hamvention last week, he did an amazing job and was able to get my traveling atmospheric disturbance code to run on all the southern hemisphere super darn radars, and his poster just looks fantastic. So I'm super excited about that, and that was
Very
something I
good.
really needed for tomorrow. So we've got that all pulled together, and we're ready to go to another conference. So back to Nat.
Very good. Next on the list is Michael, AAAK. Go ahead, Michael.
Well, thank you. Greetings to everyone listening. I'm kind of jealous of those who made it to Invention. Gravity wave effects. Whoa, that's a whole nother another orders of magnitude. Back to you, Dave.
Very good. Next on the list is Michael, AC0G. Go ahead, Michael.
Good evening, everybody. I too was at Dayton and had a good time. It was a bit curtailed because I had to do some running around, um, taking care of my son, who I had to run up to Cleveland and back and that kind of thing, and leave a little bit early. But it was good to see everybody. The weather was great and very stimulating conversations, and good to see the population of folks there kind of creeping back up again. Maybe not creeping, leaping. Um, I picked up a Dartmouth AM Doppler kit from Dave, and who just disappeared. No, there he is. If things are just shifting around, that's all. I got it set up in my yard, but we got to get it to talk home. I'm planning on either transporting that one up to Fargo or possibly another one. And I'd like to. I also have a site here that is the one of the SynthPi kits from uh, Dr. Rodriguez, I think, at the University of Texas, and I elevated a GPS antenna up on my my tower, and it seems to be doing okay. And so the whole GPS insight into what the ionosphere is doing aspect of things suddenly opening up to me. Anyway, back to Nat.
Very good. Next on the list, we have David in one HAC. Go ahead, David. Is he there? There he is.
Dave's not here. Good evening, everyone. Yeah, I enjoyed Hamvention. Found a few things I didn't know I needed, and had a lot of good conversations, contacts with various aspects of the hobby and the vocation. And Michael, yeah, I just checked the radio, and yeah, it is calling home. It just, for some reason, the RTL SDR dongle isn't present. So yeah, if you're willing to go into it, check it's got a connection of yeah, USB cable that's hardwired into the Raspberry Pi, and just
I'll
check
check
that
it
that's
then.
seated properly and everything.
Will do.
But yeah, it sounds like you know how to see whether it's present or not. So yeah, I notice
I
it's
will.
missing.
Okay.
Anyway,
Will
and
do.
so it will take a null data file and send that back, and those are coming back. So we know, and I can communicate with it, but there's not much we can do except reboot it. That might be the first thing to try, but maybe you've already done that.
I did do it at one point, but nothing new seemed
Right.
to come to life.
Well,
So
check
I'll,
the cable inside.
it could have come loose. I pulled some of those parts that you were storing inside out, and one of the things might have shook loose or something. So
Yeah, I might have
I'll
jostled something.
reseat things.
Anyway, okay, thank
Cool.
you. And just I'll note that the big bad sunspot's coming around again.
Yes.
And there's a
Yes.
second one that's also present. So stay tuned for Carrington Rival version 2, perhaps.
Yeah.
Yeah, I think of two of them that are competing with each other.
That's right. So could be some fun this next week. Anyway, back to Net.
Okay. I'm going to jump and catch Jim, K4BSE. Go ahead.
Good evening. Not a whole lot going on here. I'm still trying to get this RX-888 working. Haven't had much time to work with it because I've been dealing with a little plumbing emergency in the house the last few days and still can't get anybody out to help me. Although they promised me somebody tomorrow. That'll be the third day in the row that I've been promised something. Fortunately, I've got it kind of under control now. But not much happening on the radio yet. Right now, back to Net.
Okay. Well, I was going to call on Dave, but he seems to be transporting himself to some other location. Are you there, Dave?
He's muted. There he is.
I just came in here and commandeered my wife's office.
Oh, okay.
I hope I'll be able to hang on for most of this. I see that I had not had my laptop plugged in for a while, as I had been charging my cell phone. But anyway, I'll do what I can. Yeah, had a great time at Dayton, and especially talking with everybody and seeing all the things and hearing all the stuff. Now, I got up this morning and checked my email, of which there was more or less just one, which was, well, it was actually the next gen SDR list, but it seemed to be the only one paying attention. He had spotted last night. Apparently it's been out there for
He being Franco.
Franco, I'm sorry. Franco, had spotted a um, a sheet on the next generation of the Infineon Cypress FX USB now 3.2.2 interface, which means it's a 10 megabit interface instead of a 5 megabit interface, at least in the way they call these things. And so it's essentially double what we've had in the past. And I don't know how widely that word has spread, but it's been, some people seem to have had, some of the favored few have probably had some prototypes since about November or December. They're actually talking more about making stuff available in the fourth quarter. But that kind of changes a lot of thinking about new versions of radios for this project in the future, because it sounds like it's more or less the same thing, just twice as fast. Surely there'll be some gotchas in there somewhere, but that was good news, because I've been watching and watching and watching for that and never been able to find, never been able to spot anything even remotely equivalent. And suddenly here it is. So be passing on any new news on that front, because it is an awful lot easier way to make a radio um, than any other I know of. So that's been my excitement for right now. Back to
Okay.
y'all.
Next on the list is John WI6P. John, any comment?
I'll just say good evening to the group, and you're making me jealous that I haven't been able to attend the Dayton Ham Convention for many, many years, and certainly will have to do so based on all the favorable reviews. I'm also trying to get a 888 receiver online, and otherwise things are pretty much as they have been here. Back to the group.
Okay. And next on the list is Kent. KL. Oh. Is it KL5T? Okay. I was expecting a 7. Sorry.
Yeah,
Go-
KL5T. Yeah, I'm with the Anchorage Amateur Radio Club and the Radio Science and Operations Center. We're running a grade 2 up here in Nikiski, Alaska. But
Yes.
I saw the invite and I thought I should drop on. I had a few minutes and just stopping in to say hi.
Okay.
So I'll just hang out and watch. Thank you.
Very good. Well, hang on as long as you want. Next on the list, we have Scott in 5TNL. Scott's not got a mic. And then we have Tom in 5EG.
Good evening, Dave and everybody. Been working hard on trying to get the latest builds of KE9Q radio, KE9Q web, and GR-RTP all working. Made some progress. I found that the digital RF was crashing my GR-RTP, the module that Franco wrote. And once I resolved that, then GR-RTP runs fine, so I can bring samples into GNU Radio. Trying to use KE9Q web. I've got audio working. The spectrum comes up on screen, but it flashes badly. Sometimes it's single dropout, sometimes it's 50% dropouts. I can't tie it to a build. Every time I check out a different build and rebuild things, the symptoms change. And if I go back to a build that used to work, it no longer works. And so I'm not sure what's going on. I'm puzzling through all of this and trying to figure out what might change between builds, but more experiments to do. There's probably some hidden thing in there that's changing that I don't know about, and hopefully we'll find that. So at any rate, about 3/4 of everything's working on the latest build, so that's good news. Yeah, hopefully that means there's just one or two minor things to go find. So back to the group.
Okay, well, I think I called on everybody. So at this point, Nathaniel, you had a proposal that you wanted to discuss on radios.
Yes.
Why don't you go ahead?
Okay, so at Hamvention, as we know, we kind of want to, we're still trying to develop a new Tangerine SDR, a Clementine SDR. And I spoke with Tom Holmes at Hamvention, and I spoke with some other people at Hamvention. And one of the things that's come up is there's a couple of things. One is a couple of years ago, Scotty wrote a grant to ARDC for the Tangerine Mark II. Even though the Tangerine 1 had never been actually built and designed. That grant was granted, and so it was written by Scotty, and that grant was granted to the TAPR organization. So TAPR is in control of this funds. And from talking with Tom Holmes, there's still a significant amount of that grant left in the TAPR funds. I think it's around maybe 100K or something like that. A good amount of money for developing this thing. So nothing's really been done with that money yet, but it's there to develop a radio. The other thing we know is that since that grant was written and over the past year or so, we've learned about the RX 888 and that particular architecture, and we've said that we would really like to design one of our own radios that's inspired by this particular architecture because it seems to work really well. It's now been demonstrated to be doing what we needed to do with Whisper Demon and with the Grape project. There's a few things we'd like a little bit different about it. We'd like it to be out of the box GPS discipline oscillator controlled. I know there's a request. There's a need for these systems that can deterministically timestamp the samples and be able to synchronize more than one of these things together. I know that's a tall order, but that is something that's out there. And so basically there's that need for that. And I know that Dave Witten's been trying to put this thing together, has been trying to on his own work towards developing something that would basically be an RX 888 inspired TAPR product. Anyway, I think now that we've made it through the eclipse, and now that we know that grant funding is there, I think we should really kind of come up with a plan to try to develop a TAPR version of the RX 888 or that next radio. I don't think we should spend any of that grant money until we have a plan, and that plan has been approved by the TAPR board and by Scotty, and that plan has also been, and I think we need to go back to ARDC and say, hey, look, this is kind of where things are. This is what the original grant was written for, but these things have changed. Now we have this plan moving forward. And then if we get all of those approvals, then I think it makes sense to go ahead and use those resources to get this thing going. But I think it's something we should do because we certainly can't. I think it'd be bad to just leave those resources just left not being used. And I think that I think we all really want to see one of these things, actually come to fruition. So I guess I'm proposing that we try to hammer out the details and come up with a plan for, solidifying this or making it a little bit more formal than we have in the past year or so. So that's my proposal.
Sounds good.
Is there a specification for what the Clementine should be? Is that written out anywhere?
No.
Yeah, I think that'd be the first thing to do once we decide that we actually want to go ahead and go with this process is come up with the new specifications. What we had originally said was we wanted to take the original Tangerine SDR specifications and modify them to basically use those as a basis for starting with the Clementine specifications. I think off the top of my head, if I were to say that how we would change it, I'd say, or what we should do, I should say we should create something that is basically as close to the ARC strip plate, very close to the ARC strip plate architecture. So use those specifications and then say, well, can we, maybe increase the bandwidth on it now that we know that there's this new Cypress USB board that Dave Witten was talking about? I would say we need to include a facility for GPS discipled oscillators right away. Maybe have a built-in GERT board, maybe still rely on a Leo Bodner, and then also have a way of time stamping the samples. And if we can make it so that you can daisy chain a bunch of these things together so they can all be GPS disciplined and coherent phase locked together, even better. But basically, as many of those as I would say that would be kind of ideal.
I have one other suggestion, and I want to
Yes.
hear. Tom McDermott built an awful nice dual receiver, and I was wondering if some of that circuitry could be repurposed for this kind of a design. And I like Tom's opinion.
Yeah, so the design of the receiver module was pretty straightforward. It's just a dual A to D, and it's got analog front ends. It used the FPGA to do the precision time stamping. And I don't know if this new Cypress chip has a capability of incorporating that kind of functionality into it. If we got to put 3 or 4 pieces of glue logic around it or something like that. So I would say that certain parts of the circuitry could likely be used pretty easily. Everything from the antenna to the A to D converter input is probably usable. And then there'll be some other associated things probably have to be done a little differently just because of the physics of it, but certainly a possibility, and I think really worthy of discussion.
Well, I like the idea that you had 2 receivers that were in phase.
Well,
Yeah, that was made possible by the component we selected. And when we selected that part in 2019, it was about a $44 IC. And last I looked, I think that same exact IC is now over $300.
Oh, okay.
Wow.
I'm not sure, but I've heard rumors that there's not many companies left manufacturing high performance radio type ADCs, and that the sources of supply of those parts has dwindled dramatically, and perhaps that's one of the reasons that the prices have gone up. Don't really know the status behind that.
You probably have better info than I do, but I've sure seen these prices on all the ADCs bobble up and down madly, and they seem to be settling, back into a more reasonable. At least the LTC 2208s. I'm seeing them at kind of sane prices, not maybe as cheap as I'd like. The one I can't remember the name. I have the developer board for the one you have also.
Mhm.
And I think it's got real advantages if you want coherence, because they're on the same die or something. But we should keep an eye on the prices of those, because that's, and not make rash assumptions too quickly about these things. One other thing I think, as far as I can see, and I have very little information to go on this Cypress, they call it the FX10 instead of the FX3. And it does take LVDS rather than as well as LVCMOS. But in the past, we were limited to LVCMOS, I believe, weren't we? Or CMOS.
Yeah, the receiver design that we did for Tangerine, actually, you could use the SPI port to program whether it was a single-ended CMOS or double data rate, low voltage LVDS signaling. LVDS kind of has two different meanings. One of which is it's a few hundred millivolt differential signal, and another is it's a format that's bit serial, and you can clock in 8 bits in a row through the interface. And so sometimes you have to disambiguate the meanings of those two things. And I read that a couple of times, really confused the heck out of me. But the LVDS has distinct advantages, in my view, in a receiver, in that the voltage swing is a factor of 10 less. They're differential, so the noise from the swings tend to cancel out. So you get something like a 20 or so dB or 30 dB reduction in the noise from the A to Ds and into the FPGAs. So it has advantages. The disadvantages, you got to put 100 ohm terminations on it. You got to have double data rate clocks. There's all that kind of stuff. And the chip we used on the receiver had, you could adjust in picoseconds the clock timing with the data. A lot of really cool features in that chip. So those are all things. The second thing is can the Cypress part handle two receivers? Does it have logic or functionality to interleave data samples from two receivers?
It sounded to me like it did.
Okay.
It's also up to us to interleave it.
Pardon?
It's up to us to interleave it. It's not necessarily up to the chip.
Okay.
Yeah. Well, yeah, there's really not enough information to come, but I do think it sounds to me like, within 4 months or so, we'll know in that kind of time frame, maybe more sooner than that. But they were talking fourth quarter of this year. They were saying that last November, it looks like. And so, but they only talked about it at certain at certain trade shows. And, Franco dug up some information where people were complaining that they didn't give them enough data sheets.
There's never enough data sheets.
Yes.
No, of course not. And but it looks like it would be a real step forward, but it presumably is not so wildly different in concept that we couldn't continue working on stuff we have and work out the gotchas. And then the minute we have better information, we can look at what we can and can't do with more bandwidth.
Yeah, I would think, Franco, since he wrote the driver, boy, he is, if there's ever an expert, he would be the one.
Yeah.
Yeah.
Well, he was very excited about this, I think, today. So
Okay,
Yeah.
good.
I would also suggest that we need to contact John Ackerman and make sure of his bandwidth that he has available. While very interested in the project, he had 2 or 3 projects ahead of us in his queue. And some of those had severe issues that he had to work on. And so he really didn't have the bandwidth to help us. That's what I understand from him.
from what he was saying to me at Dayton,
Okay.
the main obstacle is a bug in the code that actually George is
Yes.
sorting out, but hadn't had time with the work, with the, build up to Dayton and stuff to really dig into. But I think it's just some gotcha, someplace where they tripped over their shoelaces. And
The code for what?
mhm,
Code
the-
for what?
they're using, I think, a small ST microprocessor somehow in that GERT
Yes.
thing.
Oh, you're
And
talking about the GERT. You didn't say that.
I'm sorry. I'm sorry. I was just talking about. I'm sorry.
Okay.
But in any case, we've got quite an abundance of but we've got GPS DOs to work with
Yes.
for the time being.
Well, maybe yes, maybe no. I have not seen the GERT design, and I am pulling my hair out over bad GPS DOs right now.
Well,
So
we have other.
we need a
GPS.
good one. We need one that can give us real time. Bodnars
Yes.
do not.
Right.
They aren't even close to doing that. We need real time. We need synchronized channels. I would like 4 channels, not 2, because you need 4 to do imaging. That's not a big deal, but it's very easy to synchronize the channels, and you don't need to have them all on one chip. In fact, there's reasons not to, having to do with crosstalk, but it's easy to feed them a common clock. And what else? Oh, now we keep going to the RX-888, but isn't that really in HF-103? And we're not expecting to use the tuner chip. So that simplifies things. It's really actually a very simple
It is.
design.
Yeah. And Dave, you've been working on at least doing a KiCad diagram of Oscar's boards.
Well, I have that, and I've had it for a long time, and I've had some boards made, but I was trying to be cautious, especially since I had no great, no more direction on the on where to go next. So I've been sticking with the development boards, which is surely not. I mean, they plug together onto a board that's equivalent to an HF-103, but I haven't elaborated that very far. But I have that to work with and play with. I've had those made, and we just need to do some testing and see what else is wanted. Now, as far as, I'm not sure I followed everything you said, Dave, about David, about wanting some.
I want to
4
be able to
channels.
synchronize 4 ADDs, 4 channels.
Okay, but is that not a question of for entities, a proper distribution of a single clock?
Yes.
So that, if we have a decent GPS DO, we just have to distribute it.
Well, but you have to keep them synchronized as well. You can't just sample synchronous.
Sample synchronous as well as clock synchronous.
Right.
Yeah, and that is, and I talked to Phil Karn about that quite a bit, but with many, many interruptions, and that is still, in fact, couldn't hardly finish a sentence, but as usual at Dayton, but but he's aware of the glaring need to solve that problem, at least from his perspective, and still thinks there are good solutions there.
Well,
But
as a
that's
rocket scientist, I can say it's not rocket science.
okay.
We have
Okay.
done it.
Yeah. Well, we just need to get all these great minds together and
Now,
pull it out of the bag of
yeah.
tricks.
Now, one thing to point out is that I did have a fairly good discussion with Scotty while I was at Hamvention, and he was apologetic for having dropped out and hopes that he has time to work with us again. He is very experienced at the layout of these things. I learned how much he knew about, he actually has worked with the LT2208 himself and knows the exact
he's-
layout that wants to be done with that to get the best performance out of it. So we should be definitely involving him in our design discussions. One thing I would also suggest is that we not build 500 of these things at once. We prototype it, do one prototype, then maybe 2 or 5. But there's going to be iterations involved, especially with something as high speed as this. As we found out with the Tangerine, one simple oversight in how things interface can cause a lot of trouble.
Yes.
I'm all for that.
Yep.
I agree.
At this point, I have made probably 3 spins of the board, 2 of which I thought were mechanically useless. And I have 1 that's waiting to test, of which I've only populated 1 board. But it's by no means meant to be, anything remotely a final product. We also need to keep in mind, just as a point of utility, that we have on these boards both I2C and SPI through the USB 3 interface, as well as doing the high speed stuff. It can put some control signals through, allow us to adjust things should we wish to. Yes, we lost David. Oh no, yes, you moved over. There you are.
Yeah.
And so I've been sticking a temperature sensor on there just so I have something to make sure that that side channel works, but it's a whole bus there. There's other things, and it's just people need to say what they want, and better minds need to I'll tell you what I don't want to do though, personally, is I don't want to go through Scotty's magic board layout guy. Or even his fabrication people. I really don't want any part of it.
We had some problems there.
I
And
would say we had
did
a
we
lot
ever get word back on the A to D
Nope.
cards?
Nope.
That I
Nope,
didn't get to
never,
ask him
nothing.
about.
It was
Nope,
dead
never,
silence.
And really, if Scotty's gonna take a big role in this, well, I guess that's y'all to decide. I probably
Well,
have
let's
other
just
things
say
I need to
we
do.
won't have him do all the work, and we'll be involved with it.
Yes.
I mean, any number of us have taken boards through production.
I think quite a few of this group have, and some are quite expert on this. And I don't know that Scotty's expertise is in any way unique.
Yeah, but he did say that he had gotten some very inside information about layout around these A to D chips. So we should make use of that.
I think I would lean towards listening to a lot of what Dave Witten is suggesting in terms of what way to go here, because I think he's really shown a lot of commitment to this. And I I basically I agree that maybe we should not rely on Scotty too heavily here.
Yeah, that's probably
Well,
true. Now, I will point out, by the way, Nathaniel, I'm hoping to have a real project to be using this.
Yeah.
I'll know more tomorrow.
Okay.
But you know, we're talking about multi-channel receivers and using the dual channel GPS for TEC measurements, all that stuff.
Yeah.
Well, I believe that this thing that Michael is testing for the guy in Austin is essentially a TEC. As best I've been able to find anything about, that's just TEC that project's doing. And what was it? The
The SynPy?
SynPy, yeah.
Yeah.
It sure sounds like that's what it's all
It
about.
it's not just TEC, it's a scintillation index.
Okay,
Aha.
sounds very interesting.
Yeah.
Yeah, but it just depends on how much you know, how funding is for these things.
So, Nathaniel,
Yes.
break in here. We just got Phil Karn pop in. And
Hello.
I would
Hi, Bill.
like you to
Rob's
summarize.
here too.
Yeah, well, Rob watched our discussion just a minute ago, but I'd like you to summarize where we've been talking about for Phil.
Sure, Dave. So what we were talking about, Phil, is trying to figure out the next iteration of hardware of a radio that Tapper would produce. And as you know, that the Tangerine SDR project did not pan out well. And Scotty wrote and was granted an ARDC grant a couple of years ago to develop a Tangerine Mark II. That was even before the Tangerine Mark One was done. And so I understand that those funds are still in Tapper. Tapper still has the majority of those funds available. And so what we were proposing to do was instead of coming up with a Tangerine Mark II, we wanted to develop a new RX 888 inspired Tapper radio. And we were going to try to come up with a new set of requirements and a new proposal to say, you know, what this would actually look like. And once we fleshed out those details, we'd make sure that the Tapper board approved it, and then we'd have them go back to ARDC and ask if they could use those Tangerine Mark II funds to develop this thing instead.
Okay.
So what we're discussing right now
All right. Sounds
is,
good to me.
yeah, so we're basically discussing now what the specifications and the requirements of this new system would be, and you know, kind of starting from scratch to develop a new plan.
But also picking
I'm-
some of the better parts that we've already built.
I would like to suggest, if it means anything, it may or may not matter much, but that if we are really going to do a new spec here, that we look at it in terms of being a radio built for running KA9Q radio. You know,
Yes.
if there's anything that KA9Q radio can use, well, we want to be sure and make that available. That's probably something just to think about. Not because I know of anything that's out there wanting to be done, but you know, if the whole system is designed in this kind of way.
Yeah. Well, there isn't much I need. I mean, you know, most of what I've been saying is stuff I don't want, right? Particularly
That's
in
good too.
FPGA, right?
Yeah.
I mean,
Yeah.
I suppose
Well-
there might be useful things one might do, like, I don't know, convert 16-bit fixed integer to floating point, but you know, those are all things I can do in software anyway. So if you
Bill-
can do it in software, do it in software.
I think I keep hearing a real need for time-stamped
Yeah.
synchronized samples.
Yeah. I'm not sure the best way to do that, but I still think the right direction we need to test is simply injecting one PPS into the antenna. It's simple, and most importantly, it's end-to-end. It goes in right where the antenna goes in, so you can't have any offsets, right?
That would
It has
optimally
to be
be
correct.
part of the radio design.
Right.
I don't know if you heard, maybe you have, Franco stumbled across something we've been looking for a long time, and I personally had given up on, which was that Infineon has a next generation of the FX3 USB 3 and that they're predicting it to be shipping in by the fourth quarter. That's a 10 gigabit per second
Mhm.
as these things.
It's backward compatible. I mean, most of these usually are, but
Yes, yes.
Okay.
I'm almost sure it is. We don't know. We haven't got the gory details. But
Okay.
we mostly just have a kind of a slick sheet
Okay.
showing.
The other feature you guys keep talking about are synchronized multiple channels.
Mm-hmm.
Yeah.
Is that something you can handle
Well,
or do?
I was mentioning Tom's radio board that he had built, Tom McDermott. So,
Okay.
And that, do you want to talk about it, Tom?
Yeah, but just to recap, what we did on Tangerine is we had a dual channel ADC. So 2 channels would be synchronous, and you could
Okay.
plug 2 of those boards onto the carrier so that clock could be synchronized and sent to 2 different dual channel receiver modules, giving
Okay.
you 4 channels that are bit synchronous. What we did on that board is further down the data processing chain, we marked the 1 PPS time into the outbound digital data stream because we had the parts in that whole collection of things to do that fairly easily. And all of that I think is doable. I don't know what this proposed FX10 chip would do or what kind of IO it has to be able to talk to those things. But if we can build something where we can provide the clock synchronously to a couple of A to D chips, and we can make the timestamps appear all in the same word on all the different ADCs, however we do that, then I think we come probably pretty close to what a lot of folks are looking for.
Okay, but the only thing I would argue for is doing the 1 PPS calibration into the analog input. It would account for any delays in the ADC. I mean, make it strictly end to end, right? If it's going in exactly where the antenna goes in, then it has to be right,
Mm-hmm.
Right.
Yeah, there are some issues to worry about. Is you'll get some slight differences in delay through different analog circuits, but you'd have that same problem if you timestamp,
right? That's good. If they are different, you want to know that, and I can take it,
Yeah, unless of course it causes the smushing out effect.
I don't know what you mean.
Yeah,
I mean,
I
if it's
don't know
going in
that you'd have
exactly
the
where the
bandwidth.
antenna goes in, then you're going to be, I mean, assuming the 1 PPS is accurate, which is not my problem,
I don't
then
know
you
that
will
you have
know
the
exactly
bandwidth
when
to
the
put in
sample is received.
I don't think you have the bandwidth to put in a synchronizing signal like that. It's better to just make sure that your samples are synchronous. Have them all running off a common clock and a common
yeah, but you got
timing
to do
system.
the absolute delay measurement. Maybe you only have to do it once for a unit, but you
Well,
need
yeah, there's some
to know the absolute
calibrations
delay.
you can do, and it won't change.
That's what I mean.
But it's not difficult to have multiple A to Ds sampling synchronously.
No, there isn't. But I just want to make sure that I, know that this sample was received at this time, or at least at this rising edge of the 1 PPS input.
Mm-hmm.
Right?
That's your timing system.
Yeah, so I agree. There are multiple ways to accomplish that.
That's right. It did occur to me, though, that, I mean, a single sample probably will not have enough energy to see easily unless you disconnect the RF input. So you probably want to have a switch.
Is there a method that would allow these time synchronous this to be like a distributed system so that you could have one in California and one in New Jersey?
Yes,
and
that is the reason you want them, to be absolutely have a good GPS lock on it.
Yeah,
So
when John and I talked
geometry.
about that, we were, when we built the clock module, we were seeing about 50 nanoseconds RMS difference on the 1 PPS edges.
Is 50, is
That can be
that
that can be
nominal? Can you do
improved,
better?
especially with dual
Yeah.
dual
Yeah,
carrier.
it could also be removed by post-processing, but
Right.
that can take up to 24 hours to
Well,
get.
there are ways to take the sawtooth out of it, and
Yeah,
especially as I say, when you have dual carrier receivers, the whole point there is you can get down to, essentially picosecond levels.
Yeah, at
Yeah.
that level, of course,
Yeah, we were seeing the edges moving around almost that much, just due to atmospherics.
Okay, you do know at that level you have to calibrate out your feed line delays.
Well, of
Oh,
course,
yes, absolutely.
Okay, all right.
we always have to do
And
that.
also the length of the GPS antenna feed line.
Right. That's all in
Okay.
it.
All right.
Yeah, the advantage of an analog kind of pulse is that if all of the receiver ADCs are clock synchronous, you really only need to see where that pulse shows up on one of them. And you can infer that, position on the other channels.
Well, you don't need to see it on any of them because your clock system is synchronized. You know when you're sampling.
Okay. If you know what it is, then
yeah, you need to know which sample is the time mark.
Yeah. And everything will stay synchronous beyond that point.
Right.
Yeah. You want it to, you want a periodic timestamp because things do screw up, and you can drop a sample here and there, but
yeah, it occurred to me it might be easier if you're going to have a lot of channels to have some kind of block marker, basically just to counter it. Yeah, I'm not sure this is worth it. It might be still easier to do in software, but if I have a whole bunch of these things running in parallel, I want to do the FFTs at the same time. I want the FFT blocks to align on the same samples. I'm not sure that's easy to do in software. I'd have to think about it, especially if I'm using multiple processors I'm thinking about cases where you have a lot of samples and a lot of boards and a lot of antennas, and you want to clock them all at the same time.
yeah, but if you transfer them in blocks.
Yeah, but I got to make sure I know where the block boundaries are.
That's up to the timing system.
Yeah. Well, I see. You would mark what every second you would give me a tick or something.
Yeah. Well, each block would start at the same time.
Yeah.
Or you like some of our systems our blocks are once every 1/10 of a second or so.
If it were done that way, if it's not in band, if it's not an analog signal that gets captured, how would you pass me the information about which sample is on the second? How would I know that?
Metadata. It has to have a header that
Well,
tells
how to get
when
that
it was
I have no
taken.
metadata.
Yeah, what we did on Tangerine is
I just got a raw ADC stream, right?
Yeah, well, we had 14-bit ADCs, and so what we did was set the bit 15. The overload was bit 14, and we set bit 15 on the output sample at the time of the pulse per second edge.
Okay. All right. I like that idea.
Yeah, you can do that.
That's very similar to how IEEE 1588 works.
Okay. Oh, okay. And because, we have 16 bits from the RX-888, but I don't believe them all anyway.
Yeah,
No, I don't.
There's other ways you can code that information without taking an entire bit.
Yeah. Of course, running a huge step into the analog input is kind of like the same thing, isn't it? Yeah.
So there are several approaches to be
okay. Yeah, if it's in band, that would be easy. Okay.
Yeah, the other approach is to have one ADC that doesn't listen to an antenna, that's just dedicated to listening to a pulse per second input and has no RF on it. And that becomes your reference for the other
Well,
ADCs.
You can synthesize that. You don't have to have an
Yeah.
ADC doing it.
It seems kind of wasteful.
Yeah, I mean, that's the whole thing, is that that's your timing signal.
Right.
Yeah, if you put it in band like you just described, Tom, I mean, I didn't think of that, but that's yeah, if the word is wide enough, that'd be great.
Yeah.
It's everything I need. Then I can count blocks off of that and everything.
Yeah, its advantages that it's accurate within plus or minus 4 nanoseconds or something like that.
And I get it every
plus
second
GPS
on
monitor.
I get it every second on the second, something like that.
Something like that. Yeah, that's what we're going to do in Tangerine is the pulse per second from GPS went into the FPGA that was handling the samples out of the A to Ds.
Right.
And so it was very simple logic to just mark bit 15.
Okay. All right.
Oh, but wait a minute. If you're using a 16-bit A to D, how do you have a bit 15?
Well, that's what I was just saying. I don't believe all those bits anyway. So
yeah, well, a way to do it, for example, is to invert all the bits for the edge, or to invert a couple of bits and then later fix that inversion when you know that was most likely the pulse per second clock. Then you can undo the coding you did to signify that was it. That's done in some telecom things.
So you just change all the bits. If there are ones, you flip them to zeros and vice versa.
Right, right. One way, but you have to make sure that you don't hit the MSB of the data when you do that, or if you do, you have to hit the MSB in the next one. There are some coding rules that make it less likely to lose that information or corrupt the sample. But I think there's tricks you could do to encode the information in the data and then pull it back out again.
I'm not sure I understand that, but it sounds very, very similar to the randomization option in the LTC 2208. They take the low order bit, which is essentially random, and use that to conditionally flip all the other bits. So the idea is to randomize all the digital outputs to flatten out any cross-coupling noise that gets into the analog input. Right. I actually turn that on. Of course, I can't tell any difference, but I support that, and it's easy to turn on.
Yeah, when you do that kind of stuff, there's a couple of approaches there. But if you can find a particular data pattern that's unlikely to be seen in the real world, for example, the pulse per second edge can cause an inversion of the high order bits, regular back to the normal bits, inversion of all the high order bits. So you've got kind of like 3 samples in a row that are affected. You have something that's pretty unambiguous, because in the real world, it would take an enormous spike at 120 megahertz to cause the A to D to actually do that. And so you have pretty high confidence that was.
Well, think about the software
sample perturbation.
part. It has to run at the full sample rate that's going to, what seem like simple operations sometimes end up burning more cycles than they really should. I'm actually kind of proud of a little trick I came up with for handling the de-randomization. It was faster than than the standard code. But one thing you could do is actually very similar. Remember, you know why comm links in the old days used to be 56 kilobits instead of 64? Do you know why?
Yeah, they use robbed bit
signaling. Right.
Yeah.
They had 8-bit PCM, and they would occasionally rob the low order bit for signaling. So you couldn't rely on it. It had no effect on PCM voice, because who could hear that, right? But it did screw up. It means the path was no longer digitally clean.
Right.
Which is why you couldn't use that bit anymore. And that's why the channel capacity dropped from 64 to 56.
Right. And so,
but you could do that here. You could just use the low order bit. Nobody would care.
There's other methods that were used in DSX1 and DSX3 to convey that kind of information by doing a weird thing to the bits in 2 complementary ways. And then
this is sort of coming back to me now. It's been a long about how T1 did this. Yeah, it's
Right.
been a very long time. But yeah, you could just use the low order bit and nobody'd notice.
But
Actually, you
T1 did
do.
it one way and E1 did it.
Don't say
Yeah.
you don't notice.
I wouldn't notice. I mean, look,
But
Rob
you're
is
doing
Rob.
if you're
that's-
when you're doing
Rob
the
is here. Oh
when
well,
you're
I was
doing
going
the
to say Rob
spectrum, you
wasn't
see
here,
it.
so
Look,
we don't have to
I'm
worry about signal noise ratio.
I
and
used to
dynamic
support
range.
24-bit audio codecs, and you could see a single bit flip on them.
Yeah, really? I don't know.
Yes,
That's
really.
100. That's 150 dB of dynamic range.
144.
Okay, close to 100, 150 in round numbers. Yeah, that's a few dB among friends.
Yeah, at any rate, it's a detail that, there's, I think there's several ways to do
Don't
Yeah.
steal my bits.
it. We'll give them back later.
Nathaniel, I would
Yes.
suggest you put together some sort of a group that's going to start putting this together. I mean, we are a group, but how are we going to formalize this?
That's a really good idea. I guess we need a document. With the Tangerine SDR, we had a requirements document. Do we want to start? Can we create a committee? Can we get some volunteers to be on a committee
Oh,
to
just we need another committee.
Well,
to draft the
but
the
part of it
requirements?
is to get it down on paper and then
Yeah.
have everybody look at it.
Yeah,
You could call it interested parties. not a
interested parties,
Yes.
Okay.
Friends.
friends.
I think it's an
Good.
awfully nice thing to have when you go to document the project.
Yeah.
Uh,
Should we ask for volunteers or can I nominate requests?
Yeah, I'll be happy to author a document with sufficient contributions by knowledgeable folks.
Thank you, Tom.
Yes. Thank you.
No idiots may apply.
Well, only people who have to rate the drivers. Those are the real knowledgeable folks. Everyone else just has an
Well,
opinion.
Dave Whitten, would it make sense for you to be on this?
Well, I'd be happy to participate. I don't want to be a roadblock in any way, but I'd sure like to keep an eye, keep a clear eye on what's discussed, be included, and any other, make coffee or anything else that it might facilitate the process. But yeah, you need Franco, you need
Yeah.
you need Tom, you
Franco.
need Phil.
Dave
Dave.
Yeah.
and David. Dave and David.
David. Yes.
Right.
David squared.
So Tom,
I
would
don't-
you share
I'll
this?
I'll be the editor and whatever it is.
Okay.
If I write badly, no one will read it. So
Yes.
I
Well,
promise I'll read it.
yeah, no problem. We'll just find a Google Docs home and get it up there.
Okay.
Yeah. I think it's a good idea.
Yeah.
Even if we just started over again with the Tangerine spec, the way you did it before.
Okay. Yeah, I'll see what I can pull together and put out like a template and, flesh out some ideas.
Okay.
Then we'll get some knowledgeable people to actually turn it into something that makes sense.
Yes.
That sounds really good. Thank you.
Well, I
That's
have to
Yeah.
jump out of here at
I-
this point, but
And I do too, since I have to get ready for my trip tomorrow. But I think this is a really good discussion and I'm excited where this will hopefully go.
Yeah, so we will start with the software in mind.
yes.
All right.
That's
Since
what
we-
I'm hearing. You guys are all thinking software. I'm thinking hardware.
Well, we have to go at it from both ends.
Of course.
It has to be realistic both ways.
Mhm.
But
Again,
but
as
we-
I say, I've worked a lot in the digital audio industry, and people were saying, "Oh, well, we don't have to worry about analog; it's all digital now." Well, how do you get it in and out?
Yeah.
Mhm.
But, but, um, but at least we have a software target now that
Yeah.
I think that's helpful too. Because before we really didn't have it entirely specified
Right.
from that side. And we can make sure the pieces are there from either end of the stick, you know, hopefully.
Yeah.
All right, Nathaniel, I'll email you if I need a Google Groups, Google Docs place to host this thing.
That sounds great. Thank you, Tom.
You bet.
All right, everyone. I hope you all have a great Memorial Day. Good rest of the day. And I will see you next Monday.
Man,
Bill, could I have a minute of your time?
Yeah, sure.
Thanks,
I'm in
everyone.
Rochester,
You know-
I'm in
you
Rochester,
know-
New York, by the way.
You know what
Bye-bye.
the